we can relate the components of a vector to the angle that determines the vector and, of course, the magnitude of the vector. These are the formulas here, but I'm going to go and draw a picture so that it's clear why these relationships hold. I'm going to take, so I'm going to draw a vector v here. And the vector v, of course, is determined by an angle measured from the positive x-axis. Okay, we'll call that theta. That was kind of an ugly theta. Let's fix that, theta. And then, of course, its magnitude. Okay, the magnitude of v. So this here is our vector v. Its magnitude in this angle. And then we can say, okay, well, I know that I've got trigonometric functions of any angle based on kind of points on the terminal side of an angle. And so if I just think about this point right here at the end of this vector, that point, a1, a2, I know that the cosine of the angle theta, by definition, is a1 over the magnitude, that distance right there, which is the magnitude of v. Of course, then I can solve for a1, multiply by the magnitude of v, and we get a1 equals the magnitude of v times the cosine of theta. And similarly, we know that the sine of the angle theta, by definition, is a2 over that distance there, which is the magnitude of v. And so then we can solve for a2, multiplying by the magnitude of v. We get the magnitude of v times the sine of theta. And so that gives us this relationship between the components of the vector a1 and a2 and the magnitude of the vector and the sine and cosine of the angle that the vector makes with the positive x-axis.